So rate constants are easier to solve for with their numbers, but the units can get a little tricky. So we know that our units of a rate constant can vary. Let's do an example problem. So for example, let's say that our rate is equal to molarity per second because it's a change in concentration over time, right? So then our rate is going to be equal to K times, we know our reactant concentrations unit is molarity, and the same thing for our B. So then, solving for my K units, I'm just going to use regular math. So to get my K by itself, I know that I'm going to have to divide both sides of my equation by my M over M, or my 1 over M times M, because then I see that these M's cancel, and I know that one of my M's and one of my M's will cancel, so then I'm left with the unit of 1 over molarity times seconds is equal to my K unit. Hopefully that makes sense for everyone. It was just a little bit of algebra, but we're going to move down and do a little harder one now. So for my rate constant practice here, let's use this one. I'm just going to plug my units in like it's a regular algebra equation. So I have my rate in molarity per second is equal to my K unit, which I'm trying to find. And then my A is going to be my molarity. It tells me it's to the 17th. And then my B, also molarity, to the negative second. So in case you're not up with your algebra rules, we know that our M to the negative 2 is equal to 1 over M squared. That's just our basic little reciprocal. So I'm going to rewrite my equation so that it's my K times M to the 17 over M squared. So then I know that my M's are going to cancel. I know I have 2 in the bottom. That means I'm only going to be left with 15 in the top. So then M over S is equal to K times M to the 15th. To get rid of my M to the 15, I know I'm going to have to divide on this side. I'm going to cancel that. And then I know that my 15s, one of my M's on the bottom is going to cancel out and become 14 with my 1 on the top. So then my K final unit is going to be 1 over M to the 14 times S.